Next, we're going to take a look at simplifying radicals. And as I mentioned before, this is going to be using multiplication in the opposite direction, where what we're going to be doing is taking one number and variables that's sitting underneath the radical and factoring it into various pieces so that we are able to simplify. And the key here is the factors that we use, we want to be perfect squares. So let's take a look here at some vocabulary before we get into the examples. To simplify radical by factoring. The radical expression, it's going to be simplified. What do we mean by simplifying? When there's no perfect powers as factors. So in other words, when we are able to pull out any perfect, so if we're looking at square roots, we want to pull out any perfect square numbers that are sitting underneath that square root. If we're looking at a cube root, we want to pull out any perfect cubes that are sitting under that radical. That's what it means by simplifying. And in order to do this, there's going to be two approaches we can take, but we're going to have two different considerations, both for the numbers, the coefficients that are sitting in front. And this, as it says here, either you have to know it from memory, so you have to either recognize what the perfect factors might be, or if you're not able to do that, then there's going to be a factoring technique we're going to look at to figure out what we could pull out from underneath the radical. The coefficients are going to be the more challenging to deal with because we're going to have to either know perfect powers of numbers or go through the factoring. When we're looking at variables and taking the roots of variables, on the other hand, I think those are more straightforward to do because what we do there is we look at the exponent of the variable and we just divide it by whatever the root is. So if it's a square root, we're going to divide the exponent by 2. If it's a cube root, we're going to divide the exponent by 3. If it's a fifth root, we're going to divide the exponent by 5. And so I find that easier than finding the roots of the numbers. So let's take a look at this first example here. We're looking at the square root of 80. So before I said there's going to be factors we will come up with, but they're not going to be useful. In this case, when I look at 80, one of the things I think of is, well, 8 times 10. Yep, 8 times 10 are legitimate factors of 80. However, neither 8 nor 10 are perfect square numbers. So that's not helpful to us because we're looking to simplify here. So let's consider some other factors of 80. And we could think of square root of 4 times the square root of 20. Okay? Square root of 4 is 2. And now we still have the square root of 20. And if we think of the factors of 20, we could factor 20 as 4 times 5. And now the square root of 4 is 2. So we have a 2 times a 2 on the outside of the radical and the 5 underneath. So 2 times 2, this would be 4 square root 5. Now, maybe some of you up here recognized 16 would be a factor of 80. 16 would be 16 times 5. The square root of 16 would be 4, and it would be 4 square root 5. I didn't think about that. So I went this longer route. But if you are familiar with your perfect squares, this will be more comfortable or less so. Now, another technique that you could use would be to look at the factors of what's under the radical and take them down, make a factor tree, and factor them into their primes. So let me change up the color here. So for 80, come over here. 80 would be 2 times 40. 40 is 2 times 20. 20 is 2 times 10, and finally 10 is 2 times 5. So when I look at these factors of 80, I have 2, 2, 2, 2, and 5. So up here, let's write all the factors of 80 down. 2, 2, 2. So the first 3 2s, then the fourth 2, and then the 5. So we take the number under the radical, we factor it into its primes, and now we replace the number under the radical with its primes. The rule is, in order to pull a number out, you need to have a certain number. For square roots, that number is 2. So you need 2 factors inside that match to pull one out. So I'm seeing 2 2s there. So I'm going to cross that out. And then let me go to a different color here on the outside. This would be 2. So I pulled 2 out, and there's 2. I'm seeing another set of 2s. Cross those out under the radical and put another 2. So notice every time I have 2 that I cross out, it's only 1 that sits on the outside. And then finally here, there's 5, but there's only 1 5, so I can't do anything with it. So when I look at this, 2 times 2 is 4. So the answer here would be 4 square root 5. Same answers here. Same answers, just different technique. Next example, now we're looking at the cube root of 40. So we need to consider our perfect cubes. So if we do that, you might remember that 8 is a perfect cube. So we have the cube root of 8 times the cube root of 5. 8 times 5 is 40. Again, there's other factors here. We could do 4 times 10, legitimate. 4 times 10 is absolutely 40, but 4, it's a perfect square, but it's not a perfect cube. So that doesn't help us. So when we factor here, we want to consider the perfect squares, cubes, whatever is appropriate to our example. Cube root of 8 is 2. So our answer would be 2 on the outside of the radical, and then the third root, the cube root of 5, sits. Again, what if you don't remember those? The approach would be, once again, to factor 40 into its primes. So 40 here, I could factor 40 as 5 times 8. I mean, I could start with 2 times 20. I'm just starting with 5 times 8. And then 8 is going to be 2 times 4, and 4 is 2 times 2. So when I look at the factors of 40, I have a 5, a 2, a 2, and a 2. So writing them here, cube root of 40 is going to be 5 times 2 times 2 times 2. So I replaced the 40 with the prime factors of 40. Again, we're going to look for a certain amount of the same factor in order to pull one out. For cube root, you see the 3 here. That number is, we're going to need 3 underneath the radical in order to pull one out. So 1, 2, there's 3 2s. I'm going to cross those out and put that 2 in front. So our answer would be 2 cube root of 5. Same answer that we got in the other method. Example here, we have, now we're looking at the fourth root of 32. So we want to consider factors of 32. So I'm thinking 2 times 16, and as it happens, 16 is 2 to the power 4. So 16 is a number that's a power of 4. So I can factor this as 16, 4th root of 16 times 2. So 16 times 2 is my 32. And now, just to be consistent with the others, maybe you're thinking, well, hey, what about 8 times 4? Yeah, 8 times 4 is 32, but they're not perfect powers of 4. So they're not useful for us to simplify. And now looking at the 4th root of 16 would be 2. And now this just sits. We can't do anything with that because it's not a perfect power of 4. This would be our example. Now, if you're saying, whoa, I never would have come up with 16 as a perfect power of 4, what you could do, I'm not going to take the time to do it now, but what you could do is factor 32, 2 times 16, then 16, 2 times 8, continue down into your prime factors. And what you would end up with is 2 times 2 times 2 times 2 times 2. So that would have been your prime factors that you would have gotten. Because this is the 4th root, we need 4 of the same to pull 1 out. So we cross those out, and now we have a 2 sitting in front. So our answer here would be 2, 4th root 2. Okay, we're not going to consider this example. So this will be the last example of this type. So here we have now introduced variables. So we're going to have to consider not just the number 200, but the variables. So 200, well, we can think of 200 would be 2 times 100. And because this is looking at square roots, 100 is a perfect square. So I could factor this, 2 radicals, one with all the perfect squares and the other with the leftovers. So 200 would be 100 times 2. 100 is a perfect square. Remember, for the variables, I said we will be dividing the exponent of the variable by the appropriate number associated with our root. Square roots, that number is 2. X squared, we can divide 2 by 2, so x squared is a perfect square, so I will put it in this first radical. Moving on to the y, that exponent of y, the invisible 1, let me write it in, and 1 divided by 2, that's going to give us a fraction. We can't divide it evenly, so y is not a perfect square, so I'm going to put it in this back radical here. That will just continue to sit in the radical because there's no perfect squares. So now let's take our perfect squares. Square root of 100 is 10. Square root of x squared is x. And remember, at this point, we are going to put that x in the absolute value bracket to show that it can't be a negative number. We're only considering positive square roots. And then this square root 2y just continues to sit under the radical because it no longer contains perfect squares. So this is what we mean by simplifying. Taking the information under the radical and breaking it up into either 2 radicals in a situation like this, where we can take the perfect squares. When we do the prime factorization, we didn't use more than 1 radical. We listed all the factors underneath and took our, well, this was the 4th power, and did our simplification there. But in this, to simplify, we take a product, if you will, and we break it up into factors in order to simplify.